crystal field splitting. Of tetrahedral complexes. See, don't write. Generally, tetrahedral we write like this. This is the tetrahedral we write. But actually, tetrahedral compound can also be shown like this. See here. It is like this. These two are on the plane of the board. This, okay? So it is L. And one will be above the board. And other one will be behind the board. Okay, so now see here. If this is z-axis, this is x-axis, and this is y-axis, how can you get this structure? You can get this structure only when the ligands approach not along the axis, in between the axis. See, I have compared it. It has come in between the axis, in between. So, in case of octahedral complexes, the ligand has approached along the axis. In that case, in octahedral complexes, ligand approached the central metal ion along the axis. It is X, Y, and Z axis, by which the repulsion occurs between the the lone pair of electrons of ligands and dx square minus y square and dz square orbitals of central metal ion, by which their energy increased and the degeneracy d orbitals was lost. It's lost. This is happening octahedral complexes. Write down. This is only for your understanding, for not for exam. Tetrahedral complexes. Ligands approaches the central metal ion or atom in between the axis. By which the repulsion occurs. With the dxy, dyz, and dzx orbitals. And their energy is raised. So now it's just opposite. In case of the tetrahedral complexes, octahedral complexes, we find dx square and dx square minus y square and dz square orbital has gone up, and dxy, dyz, dzx went down. So we call that down one as T2G and upper one as EG. In this case, it's just opposite. Okay, so please write it. Then after that, I'll draw it.
Excuse me, sir.
Yes.
Sir, what's that between the
Between the axis.
Okay, sir. Thank you, sir.
we'll do it. See, this is what dx square minus y square and dz square. What we are going to write here? Eg. And these are dxy, dyz, dzx. What we will call it? G2. Okay. This is delta T. In the octahedral complexes, we have written delta O, and here we will write delta T. What is this? This is crystal field splitting energy. In short, what we write? CFSE. Now, what is this? This is 5/3 delta T. I told you how to find. See, total is 5. This top is there now, so I have to divide by this. And this will be 5/2 delta T. So, this so you know. What should we write here? D orbitals of free metal. So what we write here? D orbitals in spherically symmetrical crystal field. Okay. So what will write? What is the name of this figure? Crystal field splitting of in tetrahedral complexes.
Excuse me, sir. Sir,
Yes.
yeah, sir, the one that is in the moon.
Oh,
Sir.
this is T2G Kun. See, 1, 2, 3. This, can you see this one? See, this is T2G. See, 3 orbitals T2G, 2 orbitals EG. You always remember. 1, 2, 3 T2G. And here 2 EG. Okay, understood?
Yes, sir.
Yeah. Here it is delta T. T is small. T is subscript. Crystal field splitting energy. Crystal
Thank you,
field
sir.
splitting. Okay. Now we'll go for, you'll do. This is your work. D1, for strong field ligand, you know, splitting will be more. For weak field, the splitting will be less. So now, do it for D1, D2, D3, do. D4, you should know, up to D4. Up to do D3. Look at the previous diagram, but only thing is that it will be just opposite. Okay, D1, D2, D3. And for strong field ligand, what will happen? Give it like this. And for weak field ligand, how will you write? You make a practice so that you will not make mistake. This is strong field ligand, weak field ligand, like right here. And you also have to write the electronic configuration. Right. It will take only 10 minutes. Right. See now, I'll go for D3. D3, See. 1, 2, 3. So it will be 1, 2, 3. Okay? So it is strong field ligand. So what will happen now? 1, 2. In strong field ligand, splitting is more. So in that case, there will be pair. So what is the electronic configuration? It is EG3, E2G, 0. Okay, and now when I go for weak field ligand, I'm not writing, I'm feeling lazy. You will write it. Okay? Oh, okay, I'll write. Otherwise, so, because I don't trust you, dangerous people. See here, for weak field, 1, 2, and this is the one. Here we write strong field ligand. And here we'll write weak field ligand. So what is the electronic configuration here? This is D3. 1, 2, 3. 1, 2, 3. Now, weak field ligand. What is electronic configuration? Electronic configuration is EG2 T2G.
Please show of D2 also.
Huh?
Sir, can you please show of D2 also?
Ooh. Boleh?
I'm still confused.
See, D2 means how many? 1, 2. Une? See, une can tell more. So it will go here. So whether the weak field ligand or strong field ligand, same only, because there will not be any pairing. See here. So this is for D2. For strong field ligand is this, weak field ligand is this. Do. And what will be the configuration? Une can tell R, une 0. This is for D2. Then after the D2, have you written D3? Then write D2. Explain the magnetic behavior of Cu NH3 4 2 plus ion by CFT. Do it. I will not do. You know how to do it. You have to find out the oxidation number of copper. Achha, now only thing I will give you, atomic number of copper is 29. So find out the oxidation state, and you know what is the nature of ammonia, and draw it and find out. That I will not do. Everything I cannot do for. Oh, God, who dies? I'm Jahara. তোমরা তুমি তো একটু আগে তো স্কোয়াশ দিয়ে দিলাম
তখন তো জল আসেনি। তুমি যখন স্কোয়াশ দিয়েছো তখন তো জল আসেনি।
you do what? This plus. Then, what is the electronic configuration of copper?
AR4S1 3D10.
Good girl. So this copper is what? 29 AR 4S1 3D10. So, kumnone. 3D9 4S0. So you have to put 9 electron here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6. 5, 6, 7, 8, 9. Ammonia is a strong field ligand or weak field ligand? Hello. Ammonia is strong field or weak field? Huh?
Strong feel.
I could not understand. Tell loudly.
Strong, sir. Strong feeling.
Yes. So this will be the splitting. Okay. So what will happen now here? See here. So splitting will be more. So 1, 2. Then the third will go here. Fourth will go here. Then 5. See 4, 5, 6, 7, 8, 9. So in that case, you will find it is paramagnetic because it is having an unpaired electron. So what is the electronic configuration here? Eg4 and T2G5. Okay, we will not write anything here, strong field ligand, because all of us will know. What is this? This is D9. So it is paramagnetic due to the presence of 1 unpaired electron in T2G level. NiCO 4. Sorry, 4. Please do. Nickel 28. Nickel 28. Do. Now you know how to do. Place carbon monoxide is a neutral ligand. So oxidation state of nickel is
+2.
huh? No, dear,
sir.
it is 0. See, this is neutral though. Does it have any charge outside? No. So it is oxidation state of nickel is 0. So what is the electronic configuration?
4s2 3d6.
So it is here. Sorry,
3D10.
4s2 3d8. So it is d8. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So this is this. 1, 2, 3, 4, 5, 6, 7, 8. So this is carbon monoxide is a strong field ligand. So 1, 2, 3, 4, 5, 6, 7. Field theory could explain the color of the coordinate compounds. See, how does it explain? Okay, first we'll write it. Color of coordination crystal field theory would explain the color of coordination compounds. Most of the transition metal complexes are are colored in their solid as well as in solution form. They absorb certain radiations from the visible region of the spectra. And as a result, the transmitted or reflected light is colored. In case of transition metal, complexes, the energy difference between the two sets of d orbitals. What is this? T2g
দেখো কত বড়
Eg is very small. When visible light falls on them, the electron get excited and raised from lower set of orbitals to higher set of orbitals. See here, in case of octahedral complexes, lower set is T2G. In case of tetrahedral, it is Eg. To higher set of orbitals, in case of octahedral complexes, it is Eg. N for tetrahedral complexes is T2G. See here. In this process, some selected wavelength of visible light See here. In this process, some selected wavelength of visible light correspond to energy difference between these two orbitals. What is the difference? That much amount of energy it will going to absorb from visible light. So whatever amount of energy they require for excitation, that will be absorbed. Rest of the light will be reflected back.
চুক্তি কাটার সময় তুমি লাউ পাতলা গুলো এগুলো তো করো না, এগুলো কেটে রাখলে আমি সকালবেলা এসে সিদ্ধ করতে পারবে।
What will write now here?
না হলে তো দেরি হবে একটু রান্না করতে।
This
কারণ এখন দেরি করতে হবে না, না?
this phenomenon is called DD transition. So this is the one which I told you in transition method. It's called DD transition. This is the full explanation, but in exam, what you will write? Why transition metal compounds are colored? Then you write the transition metal compounds are colored due to the presence of unpaired electrons, which undergoes DD transition in one line. This is the whole explanation I have done. Okay. So first day we'll do one or two examples. I told you, no, this chapter, usually mark is 3, but it requires longest time to explain.